All right, today we're going beyond AI that just talks. We're going to dive into the really exciting world of AI that can actually do things, turning a simple request into a real concrete action. So let's get into it.
So let's just start with this one big question. What if the AI you use every day could do more than just spit out text? What if it could actually take action for you? I'm not talking about just answering a question. I mean, actually booking your flight or scheduling a meeting. This is the whole idea behind what we're calling Agentic AI.
And this right here, this shows the fundamental shift perfectly. You see, a standard chatbot, it takes your input, runs it through a large language model, an LLM, and then it just gives you text back. Simple enough. But an AI agent, that's a whole different ballgame. It takes your input, uses that same LLM to reason, and then here's the key part. It produces an action. It might call an API or run a piece of code. It's the difference between a passive response and active execution. To get a little more specific, what we're often talking about is an API agent. You should think of this as an AI with a mission, right? Its goal isn't to chat, it's to get something done. It's handed a toolkit, basically a set of APIs or functions, and its entire job is to figure out which tools to use and in what order to make your request happen. Okay, so that brings us to the really fascinating part. How does this thing actually work under the hood? How does an agent connect the dots between your text and a real digital action? Well, it's not magic. It's actually a pretty clever logical pattern. The secret sauce for a lot of these agents is a framework called the React pattern. And the name says it all. It's a combination of reasoning and acting. It's the simple but really powerful idea that creates a loop. The LLM can think about a problem, take a step, see what happens, and then think again based on that new information. And what's really cool is how this breaks down that loop. So let's walk through it. First up is the thought. The LLM thinks, okay, the user wants the weather in Paris. I'm going to need a weather tool and a location. Then comes the action. It picks the get weather tool and plugs in Paris. Next is the observation. The tool runs and comes back with, say, it's 15 degrees and sunny. Finally, the agent uses that observation to put together the final answer. The current temperature in Paris is 15 degrees. And for really complex stuff, this whole cycle can just repeat over and over again. So the agent has its thinking process locked down with that React loop. But what about the act part of it all? What are the actual building blocks that give an agent its power to get things done? Well, an agent's power really comes down to its toolkit, which has three main parts. First, you've got tools. These are its connections to the outside world, like an API for weather or a function to search a database. Second is structured output, which is just the ability to format its answers in a clean, predictable way a program can actually use. And third, you have memory and retrieval, so it can remember what you talked about before or look up facts in a knowledge base. Let's drill down on tools for a second, because this is absolutely crucial. The LLM isn't actually executing the code for that weather API itself. Think of it more like a switchboard operator. It looks at your request, decides the getWeather function is the right one, and then it just spits out the parameters needed, like the city name. It's your own application code that sees that output and then actually makes the call. So the LLM decides what to do, and your code is what does it. And this is exactly why structured output is so important. For that handoff from the LLM to your code to work smoothly, you can't just have it giving you messy, free-form text. No way. You need to force the LLM to respond in a really predictable format, usually something like JSON. And if you're in the Python world, libraries like Pydantic are just fantastic for this. They let you define exactly what the output should look like, ensuring you get clean data every single time.
And, as developer Dave Ebelar points out here, real-world tasks are almost never a simple one-shot deal. A request like plan me a marketing campaign isn't just one API call. It's going to take multiple steps, right? You got to brainstorm ideas, maybe generate an image, and then write the social media post. It's a sequence.
So this leads us to the next big challenge. If a task needs multiple steps and different tools and maybe even some branching logic, how in the world do you manage all that? How do you orchestrate that entire complex workflow? Well, this is where dedicated frameworks become your best friend. Two of the biggest names you'll hear in the open source community are Llama Index and LangChain. They don't replace the core ideas we've been talking about, but what they do is provide the high-level architecture, the blueprints really, to build, manage, and scale these complex, multi-step agent systems. And if you look at them side by side, you can kind of see where each one shines. Llama Index is your go-to for anything data-heavy.
If your agent needs to be an expert on a massive library of documents, its Advanced Retrieval Augmented Generation, or RAG, is just top-notch. LangChain, especially with its new LangGraph module, is fantastic at orchestrating these really complex, stateful agents that need intricate multi-step logic. Think of it like building a flowchart for your AI. Now, no matter which framework you use, there's a really powerful design pattern called prompt chaining. The idea is, instead of writing one giant, super complicated prompt, you break the task down into smaller chunks. Step 1 gets a prompt to, say, extract key details. The output from that then becomes the input for step 2, which has its own prompt to generate a plan, and so on. This just makes the whole system more reliable and, trust me, way easier to debug. Okay, we've gone through the theory, we've talked about the tools for building these amazing agents, but before you get too excited and deploy one, we need to have a serious reality check. What are the practical dangers when you put these things out into the wild? All right, let's talk about the single biggest, most common mistake that developers make, and that's embedding your secret API key from a provider like OpenAI or Anthropic directly into your front-end code. This is a massive, massive security risk. And why is it so risky? Well, here's why. Because literally anyone with a bit of technical know-how can just inspect your app's code, find that key, and start using it for whatever they want. We've seen horror stories of malicious actors stealing these keys and racking up huge bills on someone else's account. We're talking tens of thousands of dollars, sometimes in just a matter of hours. So the only safe way to do this is with a proper backend. And this slide shows you the correct flow. The user interacts with your app's front end, but then the front end makes a call not to the LLM provider, but to your own secure server. It's your server that holds that secret key. Your server can check if the user is logged in, apply rate limits, check for credits, and only then does it make a secure, controlled call to the LLM. You stay in complete control. It's a non-negotiable. So as we start to wrap up, let's just quickly summarize the key things to think about when you're taking an agent from a cool prototype to a real production system. First, you need rock-solid planning, so your agent doesn't just crash when one step fails. Second, you have to think about tool scaling. You can't just have hundreds of tools into a single prompt. You'll probably need some kind of retrieval system to find the right ones for the job. And most important of all, security. Never, ever, ever expose your keys. Always gate access through your own controlled backend API. And that brings us to the end. We've gone all the way from simple chatbots to these complex agents that can actually reason and act in the digital world. So I'll just leave you with this one question to think about. With all these building blocks in mind, what's the first real-world task you'd give to your own AI agent? The possibilities are really just beginning. Thanks for tuning in.